Hey friends, here is a nice problem. 1421 into 1423 into 1425 divided by 12. What is the remainder? Obviously, we should not do this entire calculation manually. Then it will become very cumbersome. These kind of problems, there's a small trick. How do we express this in a different way so as to calculate this remainder very easily? Let us take this example. A plus B into A plus C into A plus D by A. In this case, let's say there is A in all the three cases by A. Right, what is this multiplication? A plus B into A plus C into A plus D. This multiplication will have, there are three terms, right? This multiplication, if we expand this, we get this one. There are eight terms here, right? One, two, three, four, five, six, seven, eight. What is this multiplication? This multiplication is basically taking one out of this two and taking one out of this two and taking one out of this two. So basically, it is combination of one from here, one from here, one from these two, one from these two, one from these two, one from these two. So how many total elements will get? So two. There are two choices here. Two into two, total eight. That is this eight. All eight combinations. One from here, one from here, one from here. Here AB you can take one of A and then A or A and then C, A or AAD or ACA or ACD likewise. Right. So we can take one out of these two, one out of these two, one out of these two every time. So every time three such sets will form. So total we have 2 into 2, which is 8. Those are these 8s. Right. The multiplication is three three sets, right? Every item will have three elements, right? For example, A cube is A into A into A. A square C is A into C. Right. For example, A square C is A into this C into this A. Likewise. Right. So now if you see when we are doing this kind of multiplication, everywhere we get three elements, every term will have three elements, one of these three. Now if you see in all of these elements, there will be A except the last one, except the last BCD. Right. BCD is the only way where we can form a term of three elements without A. Right. Everywhere else, if we remove one of the B, then obviously then a B or C or D, then A will come. Right. In this entire expansion, BCD is the only term which doesn't have A. Right. There is no other way, right? Because every item is a set of three element item. Three element item. Three elements and we have four A, B, C, D. Right. The only way to pick three elements without A is BCD. All other combinations will have A in it naturally. What does that mean? This entire expansion A plus B plus C, A plus B, A plus C, A plus D, we can write it as some multiple of A. So A into K plus BCD. This entire expression we can replace it as A times some constant, some K, A times some K plus B plus D. Now if you divide it by A, obviously A K by A, the remainder will be 0. Right. So the remainder would be equal to BCD by A. Right. Whatever BCD, when it gives a remainder, that is the remainder. Because this entire expression, whatever except the last term, is anyway multiple of A. So that means this entire expression will not give any remainder. This entire expression will give a remainder of 0. Only remainder that we get is possibly BCD. Right. Now this 1421, 1423, 1425. Right. Let us try to express in a way which makes the problem simple for us. 1421 is actually 1416 plus 5 because 118 into 12 is 1416. We just divided 1421 by 12. We have got 118 point something. So then we decided let's take this number A as 1416. Right. Then 1416 plus 5, 1416 plus 7, 1416 plus 9 by 12, the remainder of this expression would be equal to remainder of 5 into 7 into 9 by 12. just because of this. Because once we expand, everything else is a multiple of 1416. When expand, this numerator will expand into eight terms of three elements each, and all seven elements are multiples of 1416. Only the last element, that is 5 times 7 times 9, is the only one which is not multiple of 1416. A multiple of 1416 means it's a multiple of 12 and it will not leave any remainder. So only thing that is left is 5 into 7 into 9 by 12. Right. 5 into 7 into 9 is 315. Right. So we have to just solve for 315 by 12, whatever is the remainder. So 26 into 12 is 312. So the remainder is actually 3. So this entire problem, it just boils down to what is the remainder of 5 into 7 into 9 by 12. Right. Hope you understood. We used a similar phenomena in one of the earlier cases, similar logic, while using binomial theorem. Right. For example, x plus y whole power n, x plus y whole power 1 is actually nc0 x power n y power 0 plus nc1 x power n minus 1 y power 1 plus ncn x power 0 y power n. We also earlier also we decided that all the expressions except the last expression, express the last term, is actually a multiple of x. Right. So when x plus y whole power n, if you write, we can, it's actually equal to x into some k plus y power n. Y power n, because everything else is some multiple of x, x power n or x power n minus 1 or x power whatever, x power 1, x power 2, but definitely everything else is some multiple of x. Right. So this x power x plus y whole power n, if it is divided by some let's say some x, right, then this is equal to y power n by x. The remainder of it will be equal to y power n by x, right? Because x into some k, when divided by x, it will leave anyway remainder 0. This we use in multiple places where we want to break some term into, say for example, 1 not 100 plus 1, 100 plus 1 whole power 25 by 100, let's say. Right. So instead if someone gives us 101 power 25 by 100, what is this? Then we'll just directly break into 100 plus 1 whole power 25 by 100. So this is equal to 100 into some k plus 1 power 25 by 100. Right. This problem becomes very easy like this. So this is a very good trick. We should know this binomial expansion result also. At the same time, this is slightly a different version of the same result. In this case, in the binomial case, a plus b whole power 3, here the three terms are actually different. But doesn't matter. There is only one term which will leave a remainder, that is b into c into d. Right guys? Hope you like this. Thank you.